Okay, welcome back to day 3 of writing trig ratios. I just want to review what we've learned previously. So we started off day 1 with tangent, or the TOA part of SOHCAHTOA. Tangent is equal to opposite over adjacent. And if you look at the triangle, I've already circled angle A. I've found out that the opposite side of angle A is 4. And the side adjacent to angle A is 3, and so I've already written the ratio as 4/3. Now I want to find the sine of angle A. Well, if I look at SOHCAHTOA, I'm reminded that sine uses the opposite side and the hypotenuse. Well, opposite of angle A is still 4, but the hypotenuse I don't know. And there was a problem on both days of practice work that required you to calculate the hypotenuse of a right triangle when you knew 3 sides. So I want to review that with you so that hopefully in your next practice you'll get it easily. So one leg of the right triangle is 3. The other leg of the right triangle is 4. So those are the A and the B portion of A squared plus B squared equals C squared. I don't know the hypotenuse, and the hypotenuse is always the C in Pythagorean theorem. This should look familiar to you. 3 squared is 9, 4 squared is 16, and we know that 9 plus 16 is 25. So right now we know that C squared is equal to 25. I don't want to know what C squared is, though. I want to know what C is. So I'm going to take the square root of both of these and find out that the square root of 25 is 5. So C, which refers to the side across from angle C in this right triangle, which is also my hypotenuse, is going to have a measure of 5. Now when I write my sine function, or my sine ratio, I find out that it's going to be 4/5. Please keep in mind there will be times when you will need to maybe use these ratios as fractions. I'm sorry, not fractions, but decimals. So just know that 4/5 can be divided out and changed to 8/10. 4/3 can be divided out and changed to 1 and 3/10 repeating. So if you need to do that, that's always an option. Okay, so that brings us to our new material, which is the cosine ratio. And I've got the same triangle over here. We just have a new learning target for today. I can write cosine ratios for right triangles. We've done the SO part, we've done the TOA part, now we're doing cosine. Cosine is always equal to the adjacent side over the hypotenuse, and don't forget that this is theta. We're getting close to getting to the point where we're going to replace that with an angle measure. Right now in our problems, most of our triangles have had letters at the vertices, so we don't have to use theta necessarily. We've been using the names of the angles. So if I wanted to know the cosine of angle A, I know that cosine uses the adjacent side and the hypotenuse, which I've already labeled in this triangle. So adjacent is 3, that goes in the numerator. The hypotenuse is 5. Hypotenuse always goes in the denominator of the cosine function. So the cosine of angle A is 3/5. If I come over here and do the cosine of angle B, adjacent to angle B is the side that measures 4. We need the hypotenuse, and the hypotenuse in this triangle is still the side that's measured with 5. So the cosine of angle B is 4/5, adjacent over hypotenuse, which is equal to 4/5. Please be sure to check out any assignments that you have already submitted. I have responded to the first day's practice. If you made some mistakes, then I tried to add some comments in there that would hopefully help fix those mistakes for later days.